Shapiro. I am a plant person. As Jay was saying, I have been breeding plants for over 45 years. Currently, I'm a staff officer for plant science and external research at Mars Incorporated and an adjunct professor of plant sciences at the University of California, Davis. I'm also a vegan, so I'm a little fanatical about getting nutrition out of plants and into people. So I want to talk about how we're going to work on the issue of making food crops more nutritious. This is me in a greenhouse. This is what we do lots of the time. We're in greenhouses, we're in fields, we're in laboratories. And as Dr. Collins said earlier, it's the ability to take information and translate it out, which really makes the difference between pure research and the work that hits the streets, as they say. And this is an extraordinary image of corn. And I have been mesmerized by plants since I was a young child. The New York Botanical Garden, the Brooklyn Botanical Gardens were really my secret worlds. And parts of my family had farms around Syracuse and on Long Island, and that was my refuge. This is where I went to go when I wanted to get away, when I wanted to immerse myself in a relationship to nature, which is so critical for a plant scientist. This image that you see of Fred Goki was taken in 1939 by Arthur Rothstein, a part of the Farm Security Administration that was sent out across the United States to record this nation for all posterity. It's a part of the Library of Congress, and all of us as U.S. citizens own this. And the reason this is an important picture is because when many of us walk out into a cornfield or into greenhouses like the one that you saw me in, most people say, well, there's not much here. It all looks the same to me. But when Fred walked out into a corn patch, when Fred went out into nature, he received an encyclopedia of inputs. He received an encyclopedia of information that was so startling that it allowed him to make decisions about what he would do the next year and the kind of corn that he would save and the relationship that he would have to those plants. And he won many awards, as you can see. One thing that we know empirically about agriculture now and in the future is that yield has always been the driving force. When my colleagues from some of the big seed companies talk, they talk about doubling the yield from 1930, 1940, 1950, and doubling it again in the future. Now, if we understand what has to happen in the world by 2050, we have to double the amount of food we produce today. Now, we are a fixed system. The water that you drank this morning out of that water fountain was Cleopatra's bathwater at some time. The idea that we have more land, as Will Rogers said, we're making more people every day, but we're not making any more dirt. So we have a limited amount of resources, we have a limited amount of space, and unless we determine to cut down every tree in the forest and use every bit of land, we have to really rethink things the way we're doing it. But it's not only food security we're talking about, it's also nutritional security. And this is an area where we often don't hear the conversation. We hear the conversation about yield. We hear people talking about productivity. But what I would like to tell you is what we have to do is we have to optimize nutrition. We have to grow plants in the areas of the world where malnutrition reigns supreme, and we have to make sure those people have an opportunity to fulfill the maximum capability that they have. Who knows where the next Francis Collins or Einstein or Howard Shapiro or Jay Walker is going to come from? But if they don't have this ability to have the kind of nutrition necessary, then they will never have what they need for their lifetime. In my hand, and that is my hand, craggly as it is, you'll see a very tiny seed. That seed weighs 1/6,000th of a gram. And a seed like this encapsulates almost all the information that is necessary to create a miracle, and a real miracle. This is a seed when it looks like it's 2 days old. Not much there, you would say. And here's what a plant looks like when it's 2 weeks old, or 2 months in this particular case. And imagine what would happen if this tree was nurtured because it started with everything it needed in that seed, and it became known as the redwood General Sherman, the largest living organism on earth, weighing as much as 6 747s. All that information was carried in that seed to grow this tall and live for 2,000 years. It was all in that seed. And in my pocket right here is a small vial of redwood seeds. And this is a forest. If you can imagine, in here is a forest. It's a forest of information. It's a forest of DNA. It's a forest of wonderment. This is one of my favorite crops. I've been working on this one for 35 years. This is maize or corn. And plant seeds are armor-plated embryos with nutrition packed all around them. And a kernel, and we're highlighting the endosperm in this particular picture, the nutrients or the nutrition that surrounds the embryo in most flowering plants is known as the endosperm. It's mostly starch, but also containing some very important proteins and oil. And given humanity's consumption of grains like corn, rice, and wheat, about 60% of our food supply is endosperm. And we have been very good at breeding plants to produce more endosperm, more calories. So on the left is a little plant called teosinte, which is the progenitor of all maize in the world. And from that, we've been able to create a crop that is grown on more acres in the United States than any other crop we have. It's been consumed by human beings. We have bred this into modern corn varieties with vast increases in yields, which have kept many, many civilizations going for the last 9,000 to 10,000 years, and we have created many, many varieties, but I'm not sure that the modern varieties had as much nutrition as the varieties or the parents they came from. And on the left, or on my left, is the corn seed, and on the right-hand side is a human analogy I'd like to make. That's the ovum. At first glance, as we see these two, you realize they're both very, very fragile. The human has to understand that it's fragile because the seed or egg resembles a cushioned embryo. But the embryo is susceptible to so many environmental challenges and nutritional problems, and that is really the issue, as is its mother. Whether it's people or plants, whether they reach their full potential, two of the critical things are genetic makeup and nutrition. You simply can't get away from this. Now, we have been selecting plants for about 10,000 years in the field. They're bred with many different techniques. But in this case, what we have to understand is, can we deliver the healthiest plant to as many people around the world? So here's a healthy child where in nutrition is key, the development of the neurological system, the development of the vascular system, the development of the skeletal system. And there are many reasons why people are malnourished and suffer from chronic hunger. Too few calories can cause death by starvation. Too few nutrients can cause irreversible damage. So what is malnutrition? It's important to remember the word mal means bad, so it's bad nutrition. An infant's lack of key nutrients can cause lifelong problems. Modern plant genomics and plant breeding can help correct these problems in many traditional food crops. And what do you get? Well, you get a type of deficiency in vitamin A, and that vitamin A deficiency leads to night blindness. And it's something most of us don't really know, but it's a huge problem in Africa from the lack of vitamin A. Normal vision and nighttime vision caused by nighttime blindness caused by a vitamin A deficiency. And then we have iron deficiency. A lack of iron means that blood cannot carry sufficient oxygen. And if you see what this illustrates, here's the red blood cell, here's your hemoglobin. And as we move forward with the heme and iron, vitality is something that's so amazing, and fatigue is evidenced in this simple picture. Iodine deficiency can cause cretinism, and we don't think of it very often, but it is a way that we have to understand some of the missing pieces that happen in the world. And folic acid deficiency can cause neural tube defects during embryonic development, and this defect is the #1 deformity in the United States. So even we're not immune to this sort of thing. In the case of zinc, it causes stunting, which we'll get to just momentarily. So stunted growth is from this moment, -9 to 24 months, is a reduced growth rate in human development, not only neurologically, but physically. And oddly enough, it is a primary manifestation of malnutrition and chronic hunger in childhood, also including this fetal development period brought on by malnourished mothers. So every hour, 300 children die of malnutrition. And this is according to Save the Children, the report, A Life Free of Hunger, Tackling Child Malnutrition, published in 2009. And this image that you'll see coming up, 1/4 of the planet's children suffer from stunting. It's one of the most horrific forms of malnutrition. And in India in particular, as much as 48% of the population suffers from stunting at -9 to 24 months. And this is the country that had the Green Revolution with plenty of calories, but not enough nutrients. And a few years ago, I was at a lecture at the Dean's Council at the University of California, Davis, and Christine Stewart mentioned stunting. And I was shocked to realize, as an erudite individual, it had never entered into my mind. And the room was shocked into silence. And I determined at that point that I had to do something about this. I could not sit in this room and think that I can go home the way I've gone home every other day. Stunted children do not reach their potential. One of the things I was able to understand from the work that was done early on at NIH on the human genome is that we now have tools to look deeper and deeper and deeper into the basics in order to be able to understand chromosomes, the scaffolds that hold it all together. What you're seeing in this particular image is that we now can see this far down. And as Dr. Collins says, the A, G, C's, and T's. We can make maps, we can make information. And when we think about it, what starts to happen is it gives me the hope that we can move forward very quickly in some of these areas. So we put together a consortium led by the African Union's President's Council, the African Academy of Science, NEPAD, the development arm of the African Academy, Mars Incorporated, World Wildlife Fund, IBM, the World Agroforestry Center, Life Technologies. A group of people got together because they said we must do something to fix this issue. So we put together a group of people who realized they had the skills to fix this. Beijing Genomic Institute, one of the greatest sequencing centers in the world. Starting out on the bottom of the picture, we're going to sequence 100 food crops. 100 food crops. When I began as a scientist and I had a Sanger sequencer I had access to, it was the size of a small bus. Now the sequencers are as small as a tabletop computer. So we're going to do the fundamental work. And then we're going to take and train 250 to 500 people in Africa, plant scientists and technicians, to take this information and to decode it. Then we're going to take it out to the field. And then we're going to do something that's most critical. We're going to transfer that information to the household garden. And the household garden, largely run by women all over Africa, is where the game will be changed. We are identifying the crops. I should say we have identified them. We're going to move forward as quickly as possible. We're going to decode 100 genomes to significantly improve the nutrition of an entire continent. what we know, starting with the seed, a simple seed, it's all carried in that seed. We are going to work on improving 100 cultivars that are the traditional food crops. And in this time, we will positively affect every child. And the key is, we can do this. There's no question about this. We can do this work. We can do it, and we are doing it. Thank you very much.